the Industrial Revolution, the time when humans finally figured out how to make machines do all the hard work for them. Well, sort of. It was like the ultimate life hack, and it changed the game forever. So, what was life like before the Industrial Revolution? Well, imagine having to do everything by hand, like literally everything. Want a new shirt? Better get out your needle and thread and get to work. Need some food? Time to grab your trusty old hoe and start farming. It was like one big, never-ending DIY project. By the late 17th century, as the world was in the midst of an energy crisis, horses were tired, oxen were overworked, and humans were, they were humans, right? The economy was predominantly agrarian and life was relatively static. People relied on traditional farming methods and handmade tools. Communication and transportation was slow, with goods and information traveling at the pace of horse-drawn carriages and sailing ships. Enter Thomas Savery, a man with a dream and a penchant for tinkering. In 1698, he patented the first commercially successful steam engine or steam pump that came to be called as miner's friend. It was designed to pump water out of mines. Savery's engine used steam to create a vacuum that drew water into a chamber and then expelled it. While it was a significant advancement, it had limitations such as the risk of boiler explosions and inefficiency at greater depths. And then came along geniuses like Thomas Newcomen, James Watt, Richard Arkwright with their own set of innovations. And just like that, the Industrial Revolution was born. First up, let's talk about the steam engine. James Watt's steam engine was a total game changer. This baby was like a powerful beast that could pump water out of mines, power factories, and even make tea. Okay, maybe not the last one, but it could do that. It was the ultimate energy revolution, the industrial equivalent of a superhero cape, and it changed the world forever. The concept of using steam power dates back to ancient times. However, the practical use of steam engines began in the 17th century. One of the earliest examples was the aeolipile, a simple steam turbine described by Hero of Alexandria in the 1st century AD. It demonstrated the potential of steam power. But let's go back to James Watt and what improvements he brought into the steam engine. James Watt was a Scottish inventor and a mechanical engineer who made critical enhancements to the Newcomen steam engine, which had been developed earlier by Thomas Newcomen in 1712. So Watt's innovations included the addition of a separate condenser, which significantly improved efficiency. This prevented the loss of heat that occurred in the Newcomen's engine from 1712, where the cylinder had to be alternately heated and cooled. Watt also introduced a rotary motion, allowing the steam engines to power machinery and not just pump water. Then the spread of steam power happened. Watt's improved steam engine quickly spread across industries. By the late 18th century, steam engines were used to power textile mills, breweries, and iron works. This mechanization drastically increased productivity and efficiency. And then one of the biggest revolutions in the history of mankind, the locomotive, the steam locomotive. One of the most transformative applications of steam power was in transportation. The steam locomotive was invented by Richard Trevithick in 1804. Trevithick was a British mining engineer and inventor who is often referred to as the father of the steam locomotive. His locomotive, known as the Puffing Devil, was the first locomotive to successfully run on rails. Trevithick's locomotive was a simple but effective machine. It consisted of a boiler, a steam engine, and a set of wheels. The boiler produced steam, which was used to power the engine. The engine turned the wheels, which allowed the locomotive to move along the rails. In 1804, Trevithick constructed the first full-scale working railway steam locomotive, simply known as the Penydarren locomotive. This engine successfully hauled a train along the Penydarren Iron Works in South Wales, moving 10 tons of iron and 70 passengers at a speed of 5 miles per hour. Despite its success, Trevithick's locomotive was not widely adopted due to technical issues and the limitations of the track infrastructure. And then George Stephenson happened, another British engineer who is often credited with the development of the first practical steam locomotive. In 1814, Stephenson built the Blucher, a locomotive designed to haul coal on the Killingworth wagonway. Stephenson's innovative use of flangelled wheels, which provided better traction on the rails, made his locomotives more effective and reliable. The pivotal moment in steam locomotive history came in 1829, a competition held to determine the best design for a locomotive to be used on the Liverpool and Manchester Railway. Stephenson's Rocket won the competition, reaching speeds of 30 miles per hour, and showcasing several key innovations such as multi-tube boiler and a blast pipe that increased efficiency. The introduction of blast pipe in the 1820s was one of the most important developments. The blast pipe was a device that allowed steam to be directed into the firebox, increasing the heat and improving the efficiency of the locomotive. Another important development was the introduction of the steam dome in the 1830s. The steam dome was a device that allowed steam to be collected and used more efficiently, further increasing the power and efficiency of the locomotive. And we call this the golden age of steam. The success of the Rocket and the Liverpool and Manchester Railway, which opened in 1830, marked the beginning of the railway era. Railways rapidly spread across Britain and the world, transforming economies and societies. Locomotives also became larger and more powerful. The developments of compound engines, which used steam in multiple stages to increase efficiency, and the use of superheating, which improved the quality of steam, allowed locomotives to pull heavier loads at higher speeds. In the United States, engineers like Matthias Baldwin and Jovis Langdon contributed to the development of more robust locomotives suited for the diverse and often challenging American terrain. The American Mogul and the consolidation types became popular for their power and versatility. The steam locomotive revolutionized transportation, making it faster, cheaper, and more reliable. Railways enabled the rapid movement of goods and people, shrinking distances and facilitating trade and communication. They played a crucial role in the Industrial Revolution, allowing industries to access raw materials and distribute finished products on a scale never before possible. The social impact of steam locomotives is equally profound. Railways connected rural areas with urban centers, contributing to urbanization and the growth of cities. They also democratized travel, making it accessible to a broader segment of the population. And then we had steamships. The steamship was invented by Robert Fulton in 1807. Fulton was an American engineer and inventor who is often referred to as the father of the steamship. In 1807, Fulton successfully launched the Clermont, the first commercially successful steamship. The Clermont, also known as the North River Steamboat, traveled the Hudson River between New York City and Albany. Its success demonstrated the practicality and economic potential of steam-powered vessels for inland waterways. Fulton's design was influenced by earlier work, particularly that of John Flitch, an American inventor who had built a working steam-powered boat in the late 1780s. However, Flitch's design did not achieve commercial successes, whereas Fulton's Clermont proved viable, sparking widespread interest and investment in steam navigation. Following Fulton's success, steamships began to proliferate, particularly in the United States and Europe. The advantages of steam power over traditional sail included greater reliability, speed, and the ability to travel against the wind and currents. This made steamships ideal for river and coastal navigation. In the United Kingdom, Henry Bell launched the Comet in 1812, the first successful steamship in Europe which operated on the River Clyde. The success of the Comet spurred the development of the steam-powered vessels across the continent. Then you had transatlantic voyages and technological advancements. The 19th century saw significant advancements in steamship technology, particularly in their ability to undertake long-distance voyages. One of the most groundbreaking achievements was the first successful transatlantic crossing by a steamship. In 1819, the Savannah, an American hybrid vessel equipped with both sails and steam engine, made the journey from Savannah, Georgia to Liverpool, England. Though the steam engine was used for only part of the journey, the crossing demonstrated the potential of steam power for ocean travel. The first steamship to make a fully steam-powered transatlantic crossing was the SS Great Western in 1838, designed by the British engineer Isambard Kingdom Brunel. The Great Western's success solidified the feasibility of steamships for regular transoceanic service and led to the establishment of the first transatlantic steamship lines. And then there was the rise of ocean liners to be witnessed. As technology advanced, steamships grew larger, faster, and more efficient. The introduction of screw propeller, patented by John Ericsson and Francis Pettit Smith in the 1830s, replaced the less efficient paddle wheels, further enhancing the performance of steamships. The late 19th and early 20th centuries marked the golden age of ocean liners. These grand vessels, epitomized by ships like the RMS Titanic and the RMS Lusitania, represented the pinnacle of maritime engineering and luxury. Steamships became the primary means of international travel and trade, shrinking the world and fostering global interconnectedness. And what was the impact on global trade and warfare of the time? The steamship's impact on global trade was profound. It enabled faster and more reliable movement of goods across the world, facilitating international commerce on an unprecedented scale. Ports and coastal cities flourished as centers of trade and industry, transforming economic landscapes. Steamships also revolutionized naval warfare. The ability to maneuver independently of the wind gave navies a strategic advantage. The development of ironclad warships in the mid-19th century, such as the USS Monitor and the USS Virginia during the American Civil War, marked the beginning of modern naval warfare. The steamship era laid the groundwork for modern maritime transport. While steamships were eventually supplanted by diesel-powered vessels and nuclear-powered ships, their legacy endures. The principles of steam power and the advancements in shipbuilding from this era continue to influence contemporary marine engineering. In conclusion, the steamship was a transformative technology that revolutionized transportation, trade, and warfare. From the early experiments of Dennis Papin and the pioneering work of Robert Fulton to the grand ocean liners of the early 20th century, steamships reshaped the world, leaving an indelible mark on history. Let's look at the spinning jenny, which weaved its own revolution. Invented by James Hargreaves in 1764, the spinning jenny allowed for rapid spinning of cotton into thread. This made it possible to produce more cloth in less time, which helped to meet the growing demand for textiles. The spinning jenny was a simple but effective machine. It consisted of a series of spindles that were turned by a hand crank. As the spindles turned, they pulled the cotton into thread, which could then be woven into cloth. The spinning jenny was a game changer, allowing for the mass production of textiles and helping to fuel the growth of the textile industry. And then we had the power loom, weaving at warp speed. The power loom was another important innovation. Invented by Edmund Cartwright in 1785, the power loom used a steam engine to power the weaving process. This allowed for the rapid production of cloth, making it possible to meet the growing demand for textiles in that time. The power loom was a significant improvement over the hand loom, which was slow and labor intensive. With the power loom, it was possible to produce more cloth in less time, which helped to drive down the cost of textiles and make them more accessible to the average person. Then we have the telegraph, the information superhighway of the Industrial Revolution. The telegraph was another major innovation of the Industrial Revolution. Invented by Samuel Morse in 1837, the telegraph used electrical signals to transmit messages over long distances. This made it possible to communicate quickly and efficiently, which helped to drive the growth of business and commerce. The telegraph was a game changer, allowing for the rapid transmission of information. It made it possible to send messages across long distances in a matter of minutes. And then we had the Bessemer process, The Bessemer process was another key innovation of the Industrial Revolution. Invented by Henry Bessemer in 1856, the Bessemer process allowed for the mass production of steel. This made it possible to produce steel in large quantities. Steel was used to build everything from bridges to skyscrapers, and it played a key role in the growth of the Industrial Revolution. The light bulb, illuminating the Industrial Revolution. Invented by Thomas Edison in 1879, the light bulb used electricity to produce, light, to lengthen our days, to shorten our nights. This made it possible to light homes, factories, and streets, which helped to drive the growth of industry and commerce. The telephone, connecting the Industrial Revolution. Invented by Alexander Graham Bell in 1876, the telephone allowed for the transmission of voice over long distances. This made it possible to communicate quickly and efficiently. Other innovations include the automobile, the airplane, again, game changers in the transportation industry. And I will take up each of these and explain the evolution of automobiles, of airplanes, of telephones in the subsequent videos. So, overall, the impact of steam power. The advent of steam power had profound impacts on society and the economy. It enabled industries to move away from water-powered sites and operate independently of geographical constraints. Factories could be built in urban areas, leading to rapid urbanization and the growth of industrial cities. Steam power laid the foundation for further technological advancements and the continued industrialization of the world. It marked the beginning of the transition to a more mechanized and interconnected global economy. But in summary, the harnessing of steam as a source of energy was a cornerstone of the Industrial Revolution. From early experiments to James Watt's groundbreaking innovations, steam power transformed industries, transportation, and everyday life, leaving an enduring legacy that shaped the modern world.